Welcome everyone to today's lesson where we will be talking about binary numbers. So our lesson objectives today are objective 1, we're going to understand what the binary number system is and what it consists of. And objective 2 is going to be learning how to convert between the number system which is binary and the other number system which is called denary or decimal. For those of you who may not know, denary or decimal is a number system we use every single day of our lives as human beings. They're the numbers 0 to 9. So it's only one number system we're going to have to learn today, but we're going to be learning how to convert between the two as well. Now before we get started with this lesson, it's very important to understand that everything on your computer, whether it is browsing the internet, listening to some podcast, watching a video, writing a Word document, browsing a database, everything on your computer is essentially made up of these binary numbers, the ones and the zeros. That includes the images that you view and manipulate and create as well. So everything you guys have been doing so far in this unit has essentially been working with binary numbers. And even though you haven't seen those binary numbers, the reason why you haven't seen them is because the computer has used an application like GIMP or like Photoshop or like Paint.net to convert those binary numbers into color on your screen. So to you, while you've been working on these images, it has looked like you've been moving color around, like you've been painting, like you've been cloning pixels around. But as far as the computer is concerned, all you've been doing is changing certain numbers in the background, and those numbers represent different colors. Now before we get too deep into this, let's just have a look at what images actually are in computing and the kind of attributes they have. So in computing, we've got two-dimensional images, and these images are made up of something called a pixel. Now a pixel is simply a single dot of color on your screen or in an image. Now images have certain attributes which go along with the image, and the most basic of those attributes is the width and the height of the image. And the way that we represent the width and the height is this with this formula, or in this format, that I've just highlighted underneath Mario. So this image of Mario has 12 pixels, or is 12 pixels wide and 16 pixels in height. And if we wanted to find out how many total pixels this image has, we only need to multiply these two numbers, and that would give us 192. Now you might be thinking, well, if we count all the red pixels, all the green pixels, all the orange pixels of Mario, it doesn't amount to 192. Well, that is because we need to understand that images are made up of squares or rectangles like this. And in this image of Mario, these white pixels in the background are counted towards that as well. Even though we work sometimes with images that are transparent, the borders of the image still make up a square or a rectangle. And that includes Pikachu over here, Luigi, and this sword item over here. Now what we've been doing with our image editing is essentially we've been working with our image just like we would with a Lego block. If I wasn't happy with the color of Pikachu's red cheeks and I wanted to change them to a different color, I don't need to throw Pikachu away completely. All I have to do is remove these two blocks and add to those two spaces the color that I want, and that would create the Pikachu that I want. And it's the same thing with your digital images. You have been essentially moving the pixels around as if they were Lego pieces as well. Now for our first activity, that's exactly what we're going to be doing. We're going to be creating an image of Mario using certain pixels like Lego blocks. So if you can download the file pixel activity, and what you're going to do is you're going to use the move tool to essentially drag these colors from the left side onto your grid here and create this image of Mario. Now you don't have to create Mario with these exact colors. You can use any color that you want, but essentially it should look like this. Now I'm going to give you 10 minutes to do this, and once the activity is over, you can continue the video. And just to demonstrate, in case you may not know, if I select the move tool, you can grab these pixels like this and move them to the grid in any way that you want, like that. All the best. So now that we've finished with the activity, let's have a look at how it is that those numbers are changed in the background. So here we go. So this slide here, what it does is it shows an abstract way of how we as human beings, so we are the number 1 down here, are essentially affecting the color that is showing up on our screen, which is up here, number 3. Now what we do when we use computers, we may not necessarily have to change a number manually by actually entering it. What we may do is use a brush tool on our screen, which is an even more abstract way which the computer uses to change these numbers in the background. But I'm just simplifying it here like this. So if we change a number using the denary number system, what that does is it affects certain transistors inside of the computer by changing them to the binary number which represents our denary number. And that changes these little switches inside the computer. And based on the pattern of the switches, your computer is able to show different colors on the screen. Now if you can imagine, your screen has essentially hundreds of thousands, if not millions, of pixels on its screen. And if you were to take each of those pixels and multiply them by the amount of transistors which represent or change the color of those pixels, so let's say you have, for example, 1 million, and each of those pixels has 24 different transistors or 32 different transistors, that would mean that there are essentially 32 million of these little tiny switches or transistors inside of your screen that make up the image that you're viewing. And that could be, for example, an image of some mountains, or maybe a skyline, or whatever the case may be. Now, what does that look like in practice? Well, let's have a look at this program here, which allows us to create images. And what we can do is we can manually enter those numbers. So what I could do is I could enter the value 200 for the color red. I could enter the value 150 for the value green. And for the blue, we're going to enter, for example, let's just say 50 on its own. So by me entering these 3 values here, what I've done is I've set up the computer, so wherever I paint with my brush, it's going to change the switches in the background to whatever binary value represents these 3 values here. So when I start painting, it's not the best painting in the world, but everywhere that I have essentially drawn with my brush, I have changed the switches of my screen to whatever values represent these 3 numbers that I've manually entered here. But as I said before, these programs are so wonderful. They give us such abstract ways of interacting with these switches that we don't even need to worry about these numbers. We can just select the color manually from this color palette over here, and it changes the numbers to represent whatever color we want. So if I want this very beautiful blue over here, then that's what the program is going to give us. Let's close that off. Now let's talk about the number systems themselves. So you might be a little bit overwhelmed here, but I promise you it will make sense because it's a number system that we use every single day and we are very familiar with it. Now before we talk about binary, let's talk about denary, the number system we use every day. Denary uses 10 digits. Those 10 digits are the numbers 0 to 9, or the digits 0 to 9. And you might think there are 9, but if we include 0, then that makes 10 as well. So within this number system, we can essentially use any of these digits to create a value. But how is the number we create given value? Well, for that, we need this thing called a place value. So the numbers on top here, I'm going to write it. These are the place values. And what determines their value is how many digits we're using. So we start off with the value, or the place value 1. And the next place value is going to be times whatever the amount of digits this number system uses. So for this, it's going to be 10. So the next place value becomes 10. And then the next becomes 100 and 1,000 and 10,000 and 100,000 and so on and so forth. Now what we can do is, whichever of these digits we put underneath these place values, that's how we give the entire number its final value. So if I was to use the digit 2 and place it underneath the 1,000, that would give us 2,000. And the digit 8 underneath the 100, that would give us 800. And 0 with 10, that would give us 0. And the digit 5 underneath the one place value, that would just give us 5. And all then we have to do is add these numbers together, and that's how we get the number 2,805. Now looking at binary, it's no different. I don't even need to explain it to you guys. I will, but it's just the same concept. Binary uses a certain amount of digits. In this case, it's 2. And those 2 are 0 and 1, which means we cannot use any other digit. So we can't use the digit 2, we can't use the digit 5, we can't use the digit 9, we can't use the English alphabet. We can't use anything other than these two numbers right here. But the rules are still the same. We've got these place values, like so. And those place values start with the value 1. And they're multiplied again by the amount of digits that we use. So in this case, it's going to be 2. So the next place value becomes 2. And the next place value becomes 4 and 8 and 16 and 32 and so on and so forth. Now, how do we create a binary number with some value behind it? Well, remember what I said, we can't use anything else other than 0 and 1. So we place a 1 underneath the 8. And that gives us, if we multiply those two numbers together, that gives us the value 8. We can take the digit 1, place it underneath the place value 4, and that gives us the number 4. And of course, we are going to put 1 underneath the 2, and then that gives us the value 2 because we're multiplying 1 by 2. And we're going to put 0 underneath place value 1, and that gives us 0. We're going to add these numbers together, and that's going to give us 8 plus 4 is 12, plus 2 is 14. So this binary number is equals to 14, which means if I were to enter 14 in one of those values for red, green, or blue, it would change the switches to something which looked like this. 1110. So that's what the switches would look like in the background, which would represent whatever color I wanted to represent. Now let's put this into a little bit of practice. Here's a question for you guys, and if you have planners that have like the traffic light system, you can use these and show them to your teacher. But if you decide just to put your hands up, or your teacher might ask a certain student, and it's entirely up to you guys. But have a look at this binary number right here. Which of these denary numbers does it represent? Remember, we multiply it with the number on top, wherever it has a 1, and then we add those numbers together. So I'm going to give you guys a minute to have a look at this, and then of course I will reveal the answer in a minute. So, if you have converted it correctly, then the correct answer should be 39, because 32 plus 4 plus 2 plus 1 is going to give us this number right here. And remember, we're only adding, or first of all multiplying, but we know what, something multiplied by 1 is going to be already, and then we just essentially add those numbers together. So 32 plus 4 is going to give us 36, then we're going to have 38, and then of course 39. Here's another question for you guys. Have a look at it. Now again, if you have answered this correctly, then the correct answer should be 86. Well done to you all. Let's have a look at another one. If you answered this one correctly, then of course you should have 115 as your answer. And just for a final one, to make sure that you've understood everything correctly, go ahead and convert this denary number into binary. If you have converted it correctly, then the correct answer should be 0001010. Don't worry about this little box right there. So now that we've understood how to convert between the two number systems, what we're going to do is play a little game called a binary quiz, which you guys will be given the link for. And the game is pretty simple. All you have to do is convert the binary numbers to denary, or denary numbers to binary. So I'm going to show you guys that just in a second. So if you've gone to the correct link, then this is what you should see on your browser. And all we have to do is press Start Game. And here we go. So, if you're given a denary number on the right, like 26, you essentially have to change these switches to whatever binary number represents 26. So I know 32 is too large for 26, but I know 16 is something we need. Now if we take away 16 from 26, that leaves us with 10. So then I know I need 8 for 10, which gives us 2 left. And then if I press 2, then that will convert 26 into binary. 10 in this case is going to be 8 and 2. And if you're given a question mark or 3 question marks like this, the computer wants you to convert it the other way around to denary. So what's 16 plus 8 plus 4 plus 2 plus 1? I do actually know this. I'm going to write 31. I'm going to press OK. And that's going to give us the correct, that's going to give us some points. Now the way the game works is kind of like Tetris. What you don't want is these numbers to reach the top, because once they reach the top, then you will lose. You can restart the game anytime you want, but let's see what kind of level you can go up to. All the best.